Picture space. Empty. Vast. But what shape does it have? It's not an easy question, because space is not just a void. It has structure, geometry, curvature, and that curvature defines everything about how the universe expands and behaves. In everyday life, we think of space as flat, like a tabletop stretching in all directions. In this kind of space, parallel lines stay parallel forever. Triangles always add up to 180 degrees. It's the kind of geometry we all learned in school. But space doesn't have to behave that way. Einstein's theory of general relativity tells us that mass and energy bend space, and the total energy content of the universe determines its global shape. There are three main possibilities. 1. Flat space. This is the intuitive universe. Parallel lines remain parallel. The angles in a triangle add up to exactly 180 degrees. Space is infinite, and it expands forever, but never curves. It's what most people picture when thinking of space. 2. Closed space. Imagine the surface of a sphere. Travel far enough in one direction, and you return to your starting point. Parallel lines eventually converge. Triangles have angles that add up to more than 180 degrees. Space is finite, but it has no edges. It wraps around itself. 3. Open space. This one is like the surface of a saddle, curving outward in every direction. Parallel lines diverge. Triangles add up to less than 180 degrees. Space is infinite, and it curves outward forever. So which one are we living in? To find out, cosmologists look at the total energy density of the universe. That means not just stars and gas, but dark matter, dark energy, radiation, and everything else. Einstein's equations link that energy content to curvature. Too much energy? The universe curves inward, closed. Too little? It curves outward, open. But if the density is just right, a Goldilocks value, then space is perfectly flat. And here's what we've learned. Measurements from the cosmic microwave background. Using data from satellites like WMAP and Planck, suggest that the universe is very close to flat. Maybe perfectly so. That doesn't mean it must be infinite, but it does mean that over the observable scale, space behaves as though it is flat. But here's the mystery. Even if the universe is almost flat, it could still be curved just beyond our observational horizon. We're like ants walking on a giant ball, seeing only a small patch, which seems flat. But the ball might curve gently beyond our view. So once again, we face a boundary, not of space, but of evidence. We can only infer curvature from what we can observe. And what we see suggests a flat universe, expanding forever, growing colder, more diffuse. But if it's even slightly curved, either way, it might have implications for the fate of the cosmos. A closed universe might someday collapse. An open one might expand forever. A flat one? It's balanced on a knife's edge. The shape of space isn't just academic. It governs how light travels, how galaxies form, how time flows. It shapes everything. And though we may never walk the edges of the cosmos or know for sure if there are edges, we can measure the angles, count the photons, and decode the clues hidden in the fabric of space itself. That is the magic of cosmology. We don't need to leave the planet to learn the shape of space. We just need to watch, to listen, to measure very, very carefully. And in doing so, we may discover that space is more than a backdrop. It's a character in the cosmic story. Curved, infinite, finite, or flat, it holds the secrets of our origin and our destiny.